Hello all, we are going to discuss in this Learning Educational Dialogue 3 the different types of kinematic pairs. In our last educational dialogue we had learnt about kinematic links. So before we proceed to pairs we need to discuss something about motions. So motion of a particle can be classified under three types. They are namely translational, rotational, and a combination of translation and rotation motion. Translation. A body has translation motion if it moves so that all straight lines in a body move to parallel positions. Rectilinear translation is a motion wherein all points of a body move in a straight line paths. Example is a slider crank mechanism that has rectilinear motion. So this slider over here moves in a rectilinear translatory motion. Rotation. In rotation, all points of a body remain fixed distances from a line which is perpendicular to the plane of rotation. This line or axis is the axis of rotation of a point. Translation and rotation. The combination of translation and rotation motion is exhibited by many parts, so the third type of motion can be a combination of both. Any body in space can exhibit three independent motion along three mutually perpendicular axes, namely x, y, and z. The figure over here shows the different axes and the translatory and rotary motions that can be made possible along these axes. As shown in figure, there are three translatory motions or motions about three perpendicular axes x, y, and z, while there is rotary motion about each of those axes. These different motions about the different three mutually perpendicular axes are called as the degrees of freedom of a rigid body in space. Plane motion. If a body is moving along a plane and if its points move in a plane which are parallel to some reference plane, then it is called to have plane motion. A body with plane motion will have only 3 degrees of freedom, that is 2 translatory motion along x and y axis and 1 rotation motion about the z axis. Mechanism. A mechanism, according to Franz Reulich, is an assemblage of resistant body connected by moving joints to form closed kinematic chain with one link fixed and having the purpose of transforming motion. We had seen this definition, but before proceeding to pairs, we need to discuss this topic of mechanisms. Now, as you can see, to construct a mechanism, we should follow some process. So, how to obtain a mechanism? For obtaining a mechanism, rigid bodies links need to be assembled with movable joints to obtain kinematic chain, and one link needs to be fixed. With this, we will be obtaining a mechanism. The purpose of a mechanism is to transform motion as per requirement. Joints in kinematics. Joints are used to connect two or more links together so that a chain, kinematic chain, is obtained, and by fixing one link of a kinematic chain, a mechanism can be obtained. In kinematics, the joint used to connect links should permit relative motion between them, and hence these joints are referred to as pairs. Joints usually tend to impose constraints to the relative motion of the link that constitute the joint. The number of restraints or constraint for a joint can never be zero. This means the joint is disconnected and the links are free to move in any direction as individual. The number of restraints or constraints for a joint can never be 6. In this case, if all the motions are constrained, then the joint becomes solid. as in case of a welded joint. So this is also not possible in case of kinematics, because in kinematics there should be relative motion between the different links. Joints and constraint motion. As we had discussed in the previous slide, that a joint imposes constraint on the pair. So they can be classified under three heads: completely constrained motion, incompletely constrained motion, and successfully constrained motion. In completely constrained motion, the motion between the two elements of a pair is in definite direction, irrespective of the direction of force applied. Then only it is called as completely constrained. Example is a revolute pair, in which there is rotary motion about the axis of this cylindrical part. However, the object cannot move in this direction because of the collars on either side of the cylindrical pair or revolute pair over here. Another example is a square section bar, which is forming a prismatic pair or joint. This bar can move in x direction, but it can't rotate about the axis. So these two represent the completely constrained motion. Incompletely constrained motion. When a motion between two elements of joint is possible in more than one direction and depends upon the direction of force applied, it is known as incompletely constrained motion. Example is a cylindrical joint. Here there are no collars on either side of this cylindrical part, so the part can rotate in theta direction and as well as move in x direction, del x direction, because there are no restraints as such. So depending upon the force applied in x or theta direction torque, there can be motions possible, and the motion depends upon the direction of force. Hence these are called as incompletely constrained motion. Successfully constrained motion. When motion between two elements of a joint pair is possible in more than one direction, but is made to have motion in only one direction by using some external means, it is called as successfully constrained motion. Example is this poppet valve. Okay, so this seat is made to be seated on the valve seat with the help of spring pressure. So we are restricting the motion of this seat by use of this spring force, and thus we are using some external means to constrain the motion, which was earlier not constrained. So by using some external means when we are constraining motions, then we call such motions as successfully constrained motion. So with this we come to the end of this learning engineering educational dialogue. In our next segment we would be discussing something about pairs. Thank you.